In the last video, we looked at SLAM. As the acronym suggests, the two main outputs of this algorithm are a localization estimate and a map. And with this information, we can start to build some autonomous capabilities into our robot. The first of those is going to be navigation. So that's where we specify our target location and the robot autonomously figures out how to safely get there. We're going to be using the Nav2 stack for this, and just like the other videos, I'm going to start with a quick overview of navigation and how it works. Then we're going to get it up and going in Gazebo, then on the real robot, and finally some extra tips and tricks and improvements. So what is navigation? We talked about this briefly in the last video, but essentially navigation is where we want to plan and execute a safe trajectory from an initial pose to a target pose. And the first piece of information we're going to need to be able to do that is an accurate position estimate. Because if we don't actually know where we are at any point in time, how can we figure out where we're trying to go? SLAM is going to provide this position estimate for us. If we didn't have SLAM or some other kind of localization system, we could try to use odometry, but that would fall apart pretty quickly. It's also worth noting that this is a different kind of autonomous operation to tracking a sensed target. We'll be doing that in the next video, and that doesn't necessarily require localization. The second thing we need is an awareness of the obstacles that are around our robot. And this information can usually come from one of two sources, or sometimes both combined. The first of those is a map. So say we've got a system like SLAM that has already produced a map for us, we can use that map as a basis for navigation. So the same obstacles that we were using for localization before now become something to be avoided. This is most straightforward with the grid SLAM type of map, where we take our occupied cells, add a bit of a buffer around them, and that's our obstacles, and then everything left is free space. But we can also do it with other types of map. Alternatively, if a pre-recorded map is not available or our obstacles are moving, then we can generate a map on the fly using sensor data, typically a LiDAR. This will prevent our robot from bumping into things, which is good, but it means it can't plan its whole trajectory from the start. It kind of needs to figure things out on the fly. So the ideal world is where we combine both of these. We have an initial map that helps us plan our trajectory, and then we can use the live LiDAR data to update this with any new obstacles or things that change along the way. All of this information will be stored in something called a cost map. Now it's worth being clear that the cost map is different to the SLAM map. It might have been based on the SLAM map initially, but its values mean different things and it's getting updated independently. So the cost map assigns a cost to different areas of the environment, where a high cost is something to be avoided, while a low cost is a safe space to go. For this simple example, where we've got an obstacle, that's going to be a high cost, where we've got free space, that's going to be a low cost, and the area kind of just near the obstacles will be a medium cost. We want to avoid that if we can, but we can go there if we have to. A navigation system will typically require other bits of information as well, things like the size of the robot, some of its dynamics, and so on. In the last video, we saw just how easy it is to get started with SLAM in ROS using the SLAM toolbox. And its creator, Steve Masensky, is back again with another amazing package, and this time it's Nav2. So just like with SLAM Toolbox, we're only going to be seeing the very tip of the Nav2 iceberg today. It's a really powerful tool that's useful for many different navigation tasks. To start off with, we've got to install Nav2. Now I actually did that in the last video, but I'll put the commands back up on screen in case you haven't done that. We have one other tool we're going to install this time though, and that's twist mux. So sudo apt install ROS foxy twist mux. Before we dive too deep into Nav2, we're going to do just a little bit of prep work. One problem that we're going to run into is that our controller is expecting the command velocities on /diffcont/commandvel unstamped, but Nav2 is going to want to be publishing them to just commandvel. Now, you might think that we can get in and just remap the topic, and that is possible, but we're going to do things a little bit of a different way this time. I'll talk through a few other alternatives at the end of the video. We're going to introduce a new node called twist mux, which takes a bunch of twist topics, that's what command velocities are, and it's going to multiplex them into a single topic. And this is useful because it allows us to do things like prioritizing certain topics and locking and blocking certain topics at different times, that sort of thing. We're going to set up twist mux to take the joystick velocity on commandvel joy and the navigation velocity on just commandvel. That way we don't need to worry about changing it right now. It'll take them both, combine them together, and publish it to diffcont/commandvel unstamped. So we're going to start by adding a new file called twistmux.yaml. And the parameters that I've got in here, so the node is twistmux, we've got an array called topics, in that we've got navigation, is on Command-Vel, and we've got timeouts and priorities. You don't need to worry too much about these. And then joystick on Command-Vel joy. So we'll save that. So we're going to hop into our workspace. And then in a new tab, we can type ROS2 run twist marks. We've got some arguments. So we've got the params file, which is in source articubot1 config twistmarks.yaml. And then we're also going to need to remap the output topic. So by default, twistmarks publishes to command-vel out, and we want to remap that to diff-cont command-vel unstamped. We'll add this into our launch files later. The other thing we need to do is modify our joystick launch file. So before, our teleop node was remapping command-vel directly to diff-cont command-vel unstamped. Now, instead, we're going to remap this to command-vel joy. So that's going to command-vel joy, then twistmarks will be taking that and publishing that out to diff-cont/command-vel unstamped. If you are using stamped twists, none of this is going to work, and we're going to talk a bit more about that at the end. So what we should be able to do now is launch up Gazebo just like normal. So I've also got RViz running here, and I'm just going to run Slam Toolbox like we did in the last video. And it's just loaded up the map that I had last time, but otherwise we could go around, drive around, creating a little map for ourselves. So then in a new tab, all we've got to do is type ROS2 launch, nav2 bring up, navigation.launch.py, and we'll set use sim time to true like normal. It'll go through, do a whole bunch of things, and then we should be able to add a new map. Set the topic to global cost map, and we can see there, we'll set the color scheme to cost map. And we can see when we hide our regular map, this is the cost map that's being used for navigation. So we can see the obstacles, the exclusion areas, and also the kind of fall off zones around them. Just enable the camera view as well so we can see it there. Now, what we can do is we can see this 2D goal pose button here. So I'm going to click that, and I'm going to request that the robot goes to here, pointing that way. And you can see Nav2 just does it. Let's change our fixed frame to map. You can see it's commanding the robot. Nav2 is generating the appropriate command velocities, sending them to the Gazebo simulation, and the robot is moving to that location. And because of twistmarks, if I want to take over and start driving with the controller, I can do that. If I let go, wait a sec, Nav2 is going to take over again. So twistmarks is prioritizing the gamepad, but when the gamepad's not doing anything, then it'll let Nav2 run. So let's try going over here. We'll see if it can get through this little corridor. Sometimes it has trouble. This last gap is only just big enough, but we'll send a pose like that. And we'll see the robot should navigate through. We can see it here on the camera, squeezing through the cones. And out the other side. Now it's time to test it on the real robot, so we've moved back inside. Now, just like in the last video, I've connected to the Pi over SSH, and there I'm running the normal ROS2 control stuff. I'm also running twistmarks on there and the LiDAR driver. Then on the dev machine, I'm running the joystick driver, so that's to get our joystick commands. I'm also running Slam Toolbox and RViz, and I've already driven around and created a little bit of a map of the room. So all we should need to do to run navigation now is to open up a new tab in the dev machine, and we're going to run that same navigation command that we had before, only this time we're going to set use sim time to false. Now that that's running, Back in RViz, all we should need to do, actually let's just add our cost map just so we can check it out. Very good. We can see there's a few stray laser points causing us some trouble, but let's try and set a goal. So we'll set a goal pose over here. And we can see the robot autonomously navigates to that location. Something else we can do that's cool is we can add a new panel. So we're going to add the navigation to panel down here. We can also click this button up here to add a new tool type, and we're going to add the Nav2 goal tool. And what this lets us do, we can swap to waypoint mode. And using the Nav2 goal button, we can specify some waypoints. So I might put one here, and then here, and then tell it to come back roughly to where it was before, but facing the other way. And then we can click Start Navigation, and it should go to waypoint 1. Then once it gets there, turn around and go to the next waypoint, and so on. This is all pretty rough because we haven't tuned it very well, but there's so much that can be done with Nav2. Now that we've seen Nav2 in action in both Gazebo and on the real robot, we're going to look at some alternatives and some improvements we can make to our setup. We saw in the last video that once we've made a map using SLAM, we can keep reusing that same map over and over again for localization. So what if we want to use that kind of a setup with Nav2? It's not too hard, there's just one little trick. So I've got things set up again here with just the simulation running, with the joystick controls, RViz and twist marks. And so what we're going to do now, instead of running SLAM Toolbox, I'm going to type ROS2 launch. And now we're going to be running AMCL. We saw how to run AMCL in the last video, but this is going to do it a bit of a quicker way. So we're going to go Nav2, bring up localization launch.py. Now we need to specify the map for this one. So I've got the map saved in my workspace. I think it's my map save.yaml. And then we also need to set use cm time to true. So that'll start up, it'll load up our old map. Now it's asking us to set the initial pose just like last time. So we've got to hop in the map frame, and I'm still sitting at the origin, so I can just specify that as my initial pose. It should receive it. And then you might remember that we need to set the durability of this topic to transient local. And there we go, our map should appear and we should be running AMCL. So this is running the map server and AMCL just like we did in the last video, but in one launch file. So now to run navigation, we'll open our other tab. We'll run the same command as before, but this time it's got one extra parameter. And this is a flag that's going to tell Nav2 that it needs to subscribe to the map with transient local as well. So it's just map, subscribe, transient local, set that to true. So that tells Nav2 to start up and to listen to the map. So now Nav2 should be running just like before. And then in RViz, we can now add the cost map in again. So we'll add that. And this is going to let us see something that we hadn't been able to clearly see before. Because as we drive around, the base map is no longer going to be updated because we're only running localization, not SLAM. But we should see that the cost map gets updated as we move. So to start off with, we can see it's built the cost map based on the SLAM map. That's great. Now what we can do, let's put in an extra obstacle. So let's go for a construction barrel and we'll drop that just in here behind the robot. We can see that it's added it there. Now if we hide this map, we'll set the alpha to 0. We can see it hasn't added anything into the localization map, but it is there in the navigation cost map. And so just like before, we should be able to now set a goal and move to it. Sorry, I'm not quite sure what happened there. I've just reset everything. So we're going to set that goal pose again. So we'll set 2D goal pose to here and it should work again. Now, something that we will find if I just take over, because AMCL's localization is a bit more rough, we'll see that Nav2 starts to put obstacles where they don't really exist. And what we'll find is that pretty soon the whole map becomes a bit of a mess. Sometimes Nav2 will clear things or just reset the whole map. This isn't Nav2's fault, it's just because we haven't tuned AMCL properly, and so the localization just isn't quite accurate. If we want to start making modifications and tuning these parameters for navigation and AMCL, the easiest way is going to be to copy the launch and config files into our own directory, similar to what we did with Slam Toolbox. So I'm just going to type copy /opt/ross/foxy/share/nav2 bring up. Then we've got the params directory, and we want to just copy, there should be a file called nav2 params. So we're going to copy all of that into source, articubot1, into our config directory. Then we want to get the launch files. Whoop. So there was one that was just navigation.launch.py, and we're going to copy that into our launch directory. And then we also had localization.launch.py. So that should add these two launch files in here. Now in both of them, they're going to have a reference to their own package. So here, the bring up dir, we're going to change this to the name of your package. So for me, that's articubot1. And then if we find where bring up dir is actually used, you can see here it's creating a path, bring up dir params, nav2 params, but you remember that ours is actually in a directory called config rather than params. And we're going to have the same thing here in localization. So we're going to change this to articubot1. Now, this one also has a path to a maps directory. We don't have a maps directory at the moment, so that's just for setting a default map if you're using the same map often. If you are doing that, you can go ahead and create a maps directory. I'm just going to leave that. And once again, change this one to config. And so that means now when we run the commands, we should be able to, instead of having launch nav2 bring up, we should be able to put articubot1 navigation.launch.py, and so on and so forth. And now that we've done that, we can tweak those parameters really easily. So you'll see the nav2 params. This is a huge file with lots of parameters. So just go ahead, start taking a look at them, playing with things. So maybe tweaking robot radius. You can start playing around with some of the inflation radius, that kind of a thing. Just see what difference it makes. While I'm here, I'm also going to take a second to copy the same launch file that we were using in the last one for Slam Toolbox. So I'm just going to go in here into the Slam Toolbox launch directory, and then we were using online async.launch.py, just so that we can modify that one in the future if we need to, and it's going to have that same thing to change. So we'll go to this, and we'll change this get package directory to articubot1. Whoop. And this one's params directory is already called config, so we don't need to change that one. This is also a good moment to note why I couldn't get localization working properly in the last video with Slam Toolbox. And that's because if you have a look in here, I needed to actually, instead of running the online async launch file, I needed to be running this localization launch.py. I'm not going to copy that over right now because it'll conflict with the one from Nav2, but it's just worth being aware of that. It launches a different kind of Slam Toolbox node to the one that online async did, and that's what's needed to do localization. This is also a good time to add twist mucks to our launch files because we're always going to be using it every time we run. So I'm going to go and find our launch sim, and I'm just going to put it here below the joystick. So I've just copied it from somewhere else, but you can see it is getting the params file. I should substitute this for package name. So params config twistmucks.yaml. So it's passing that params in, sim time to true, and then remapping command vel out to command vel unstamped. And then we just have to remember down at the end here to actually launch twist mucks. And then we'll do the same thing in our launch robot. Except this time we're not going to have sim time set to true. Speaking of twist marks, there are a couple of other alternatives that we have rather than using twist marks to forward on that command velocity. So one thing that we could do is to remap the Nav2 output to be directly on diffcont command vel unstamped, and then it and the joystick will both just be publishing on it, and it will listen to whichever one it hears. Now, it's a bit messy to do that. It's here in our navigation launch file. We could add an extra remapping here for command vel, or we could do it here on the actual Nav2 controller node. So we could add an extra remapping in here. But that gets a little bit messy, especially with Humble, where you need to change it in multiple locations. So just be a bit careful of that. The other thing you can do is if you're using Twist Stamper to stamp your twists, we can kind of let it double as a multiplexer. So here was our Twist Stamper where we were remapping from command vel unstamped in to command vel out on diffcont. Instead, we can remap command vel in to just be command vel, and then change our joystick to publish to command vel. And now the joystick and Nav2 will both publish to command vel. Twist Stamper will take it in on command vel and send it out to diffcont command vel. The other alternative is we could add a relay node that just reads the Nav2 one and republishes it to a new topic. Again, it's just a little bit messy, but yeah, a few different ways that we can do that. For the first time, our robot is doing something autonomously. That is, we can just give it a task, we can walk away and let it go about its business. So this is a good chance to start creating some more complex environments, see what the kind of limitations are, have a go at tuning it to overcome them. Thanks so much to Steve and the whole Nav2 team for creating such an amazing package for us to use. In the next video, we're going to be using a different sensor for autonomy, and that's the camera. So we're going to use the camera to detect a particular kind of object and then steer the robot to keep tracking that object and follow it around the room. Make sure you don't miss out on that. As always, there's a link down in the description to the discussion thread over at the Articulated Robotics Discourse, and that's the best place to go to let us know any questions or comments or troubles you're having with this tutorial. Thanks as always to the patrons over at Patreon. It's only through your support that this channel is possible. Thanks everyone, and I'll see you next time.